Hey guys, it's Alexei, and today we're going to be building Connect 4 using React TypeScript. Before we dive straight into the code, I did want to make one quick disclaimer, and that is to say that if you have any questions, comments, or suggestions about anything you see in the videos, from the code to how certain decisions are being made, please leave a comment and start that discussion. I got a few comments in my previous videos, and they were great, from questions to suggestions, and they were all awesome. The purpose of my content really is to share how developers think from just my perspective, how I approach problems, and I want to start that discussion so we all get into the habit to essentially discuss what we're doing, how we're thinking about problems, and grow beyond just the traditional way of people looking at like the technical problem and just how to technically solve it, but instead to look at like a more abstract level of how we decide on how to solve it. Um, so that's it. Let's get started. Same with as the tic-tac-toe app. So I've just installed the TypeScript app from this repo here, and I've disabled the linting because the linting slowed us down a lot, and I don't want that to happen anymore. So here it is, the code is running. Now, I guess before we start writing code, if anyone doesn't know what Connect 4 is, it's this game where it's a 6x7 grid, and two players take turns sliding pieces from the top, and they slide down to the bottom. And the first player to get four in a row, horizontally, vertically, or diagonally, wins. That's about it. So a lot of the logic will be similar to tic-tac-toe. If you watch the tic-tac-toe video, you're going to see some similarities, which we might want to refactor in or out at some point. So I guess let's make a game plan here, game plan of attack, which is kind of like what are the things we need to build in order for this game to work. Well, we're going to need the UI, right? So that's going to be a board, cells, and like the UI will also need to do on-click move. Like it'll have to handle that. And beyond that, that's it. That's going to be all the UI, and that's going to be pretty straightforward. There's not a lot of logic there, so that's pretty easy to knock out. Um, I'm gonna call it game constants is another thing we're gonna have to do. And what game constants are is kind of like the players, like the enumerable objects to represent the players, the game states, such as if the game has been won or lost or drawn. Um, we're just gonna have to create a set of those. That shouldn't be too bad. Um, Obviously, we're gonna need a make move function, right? So players can make a move. And finally, we're going to get a check game state function. And now what the check game state function is going to do is it's going to tell us if the game has been won by which player or if the game is ongoing or if it's draw. And ultimately, like just from these four things, we have the visual, we have some logistical stuff, we have actions, and the ending condition. That's really all there is to any turn-based strategy game. So let's get to it. I guess let's just build out the UI first. Let's create a pretty image. If you don't want to watch this, you can probably just like skip ahead to where the UI is done, because like this part is pretty repetitive every time. I will not blame you, but if you're gonna stick around, index. If you're gonna stick around, I'll do my best to entertain you with I don't know what. But so here's the board. I always make them the background black because then I'll actually know if it's rendering or not. And we need a minimum height for now. Sure, 500 pixels. And it wants to be autoed, not margined. So there's the board. Um, we'll want a render cell method and I guess a render all cells. This will have the iteration, iterate through the board state, and this renders an individual cell. And of course, we can't really fully implement this until we have a board state, so maybe that's something we want to do next. Yeah, let's do it. So in order to do the board state, we also are going to need to define some of the board constants because we're going to be populating the board state with that. And let's say we were going to throw that all into the component state because why not? We're going to try and keep this light. Let's make an interface for the board. And the board actually, sorry, no, the board should be a type. And the reason that the board is a type is because it's just going to be a list of players. Of course, players don't exist yet, so let's say enum player. So we're gonna have none, and that'll be null equals. Cool. Player 1, 2. Cool. So player represents the value at any cell of the board. You may notice that, of course, the original Connect 4 game is a two-dimensional grid, so I could represent that, nope, as a two-dimensional array, but like this. However, I'm choosing to do a single-dimensional array just because I feel like it. It's really just a stylistic choice. Either approach is fine. So next, we need the state for the actual component state. And it'll take a board of type board. We pass the state here. So notice from the highlight, it actually says P is the first prop, which means I'm passing in the incorrect value here. There you go. And it's going to complain the board doesn't exist. So we need to initialize the board. And instead of initializing it inline, I'm going to create a helper function here. Whoops. Great. Because our goal is to make everything as reusable as possible. So every time an instance of the component is created, we're going to initialize the board state by running this function. And because it's outside of the component, it's easily testable. Although I don't think we're going to be running tests today. I don't really know the fancy for loop way of doing this. So we're going to do the good old-fashioned brute force for loop. Const board. So we initialize a board, and then board.push player.none. And we return the board. So there you go. We create 42 cells of empty players. So now we've successfully initialized the board, and now we can successfully read it here from the state and map something to it. So for each cell in the board, we're going to return render cell. Board is a list, so cell should be a number here, right? Why is it of type any? Is this not? Alright, well. I need to type state here, so then the board type goes all the way to the cell. Cell is a player type. Interesting. It's not a number, like the indexes of the board? I'm going to have to confirm that later. Or better yet, let's just confirm that now. Board map for each cell. What am I doing? For each cell, I would just want to console log the value of cell. So we're expecting a bunch of nulls if it's the actual value, or we're expecting incrementing integers if it's returning a list, which are like, the indices of a list. Go to the console. Nothing's happening. That's probably because we're not calling the function. That makes sense. So let's throw that down into the render function here. Just call it. This is just quick debugging, quick and dirty. Waiting. Null, 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 null. Okay, so it's actually returning the cell value, which is great. However, do I need to know the index of the cell? No, I guess not to render it, but so the thing I'm thinking about here is this is going to need an onClick. And when you onClick of the render cell, it actually needs to know the index to know such that like when it's being clicked, that it should place a piece in the right place. So it sounds like we can't just render the cell based on the C. We actually need to take the player and the index. And let's console log the player and the index. Right? Player. Index is a number. And there you go. So now we can have access to both the value and the index. Sweet. That's great. So that makes sense. So we return that, and we're going to be returning this dot render cell of player at index. So now the render cell function takes a player of type player and an index of type number and does some stuff. What stuff does it do? What does it do? Well, it's gonna be returning a div. We know that much. And let's style that div. Class name should equal to cell. And before we continue writing anything else, let's make sure that these cells look decent. And they're going to be direct children of the board, so we can write them with the bracket there. So the width of these cells, there should be 7 per row. Right, because there's 7 columns. So that means we're going to want to calculate the width to be 800 pixels divided by 7. And let's do height. If we make them perfect squares, then 800 pixels divided by 7, the height should be the same. We want them to be perfect squares, and later we'll round the borders and whatnot. And let's make the background white because the background of the board is black. Let's see. They're not displayed inline, so they should actually probably do a vertical thing. Are they showing? No, because we don't actually render them. Yes, we just call render cells. We're not actually rendering render cells. So there you go. Now it's actually going to appear where it's supposed to. It's missing the key prop. That's kind of expected. And it's failing a lot. But here, let's just do key is equal to index right away because the index is going to be unique. I'm not sure why the app keeps re-rendering, but alright. Hello. Why is it not doing anything? Did it die? No. Did I create a new file? No. Is render cell being called? Is render cells being called? So I'm just setting up a few flags there so I can see what part of the code we actually reach. Alternatively, I'm just going to kill that tab, open a new tab. Okay, so the tab maybe got into an infinite loop because of the keys. Maybe something else happened. I don't know. But there, yeah, we hit render cells once, the container, and we hit render cell 42 times. So let's style these guys here. So each cell should be display inline block, box sizing, border box, so that when we add borders, they'll be good. This is where the piece is going to go, and these should be round. So there. Now suppose we added a margin of 4 pixels to each one. That is going to make the width and the height a little off. So the width should, by adding 4 pixels of margin, we should subtract 8 pixels from the width and the height. Oops. There, and now it's kind of symmetrical. Obviously there's still like a little more padding on the outside here, which I'll address by, I guess, adding a border to the outer layer versus the margins in between each circle. Alright, let's copy the styles over to do a progress update. This welcome to React business Let's remove it. Maybe it's just slow because I'm filming. I don't know. Very, very slow. Right, so I think it's been cut off because of the height. We explicitly set the height, and now we don't need to because we actually have the correct number of child elements to fill it up. Cool. And I'm just going to zoom out such that it fits on the screen. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Perfect. I'm going to do the boring stuff, like give it the correct color. Vaguely, more or less. And actually, I'm on a linear gradient CSS. Let's make it pretty. Again, feel free to skip this part. This is the boring part, in my opinion. I don't know how fun it is watching a YouTube video with someone picking color codes. Ain't that fun? So the thing with gradients is they make everything have a little more depth to it. Right now I gave it the same color, so there's actually no gradient from like the top to bottom. However, now I can go here and tweak the gradient as I want. There we go. So the first color is the top, and so now I can modify the top to be like a lighter blue. Whew. And the bottom is a darker blue, which I'll just leave the way that it is. Cool. Gradients make applications look a fair amount more solid as far as like thought out. And usually you have the sunlight going top down, so usually the upper direction, whether it's top left or top right or top middle, is the brighter color, and then the bottom is the base, if not even darker than the base color that you wanted initially. Okay, and then the board looks like it could benefit from some padding. I mean, as far as like setting up a basic game, I think we're good. Almost looks like the original, am I right? Don't sue me. Um, cool. So, we've successfully rendered stuff. Now, we want to be able to handle the onClick. So let's say onClick, we're going to call a function this.handle onClick, and then at index. Public handle onClick. So there's a few ways we can implement this function. We could take an index, but realistically we don't actually move directly to an index, we move to a column. And a column only has values 0 through 6, whereas the index can be 0 through 41. So this could actually just take a column of type number, and here we can do index mod 7. I don't know if like converting this here, or we could also do that conversion here of like take the index, get the column from the index. I think that's fine actually, yeah. So we pass in the index, here we get the index, and then const column should equal to index mod 7, which returns the remainder. And then imagine we had a like this dot make move at column. So let's stub out that function. Public make move, which takes a column of type number. Console.log making move to column. Alright, so the rough idea of making moves per column now is pretty on click. On click. How do we get an on click for a div? Or if this is a typing issue, then I'm just going to ignore it. Pretty sure on click is fine. Let's find out. One really easy way to find out. Okay. Type void is not assignable to other type. Does my render cell? No, it returns something. Handle on click is a function that takes an index. Oh, and it returns another function. It's because we're actually calling it on this index. Aha. So we're initializing the function here with this index, and then it returns a function that no longer needs to take an input, but when called, will actually execute this code. Of course. How could I not see it? Alright, so 0, 1, 2, 3, 4, 5, 6, 6, 5, 4, 3. Yeah, you get the idea. So the core functionality of the UI, I'd say, is done. The only thing we could actually add now is like UI to do is a blue slash, I want to stick to the original colors, red, yellow cells. Besides that, red, yellow cells, we're done. The basic UI part. But in order to track the red, yellow cells, we're actually going to have to be able to make moves. And so let's just go ahead and go straight to that. The make move function. It will probably need the board state. And what's this guy gonna do? Given a column, it needs to figure out the lowest possible entry index value that fits according to that column. So here, depending on which column you get, we actually want to run a separate search to find the lowest empty square and then place a piece there. So that should be a separate function because we're going to be calling that a lot. So like const find lowest empty index is a function, let's say, that takes a board, type board, and returns, it's going to return a number. We don't know what number yet. It's also going to need to take a column because we need to know which column we're searching for. So how is this going to work? Suppose the column is 0. We want to iterate over every 0 and then 7 and like 6, 13, etc. Okay. So I'm thinking of like, do we want to filter down the board to just be those columns? But no, we need the index. We actually have to return the index, so we can't just filter down the thing. We actually have to use the entire board to find the proper index. So instead, we could just do a for let index equal to, the index can start at the column, and while the index is less than the board.length, index plus equal to 7. We want to find, okay, so we want to find the empty the lowest emptiest index. However, when I is equal to 0, starting from the 0th board index, that's actually the top left of the grid. And we're going to find an empty, like the top row of the grid is always going to be empty. So we actually want to start our search from the bottom and work our way up, because then the very first time we find an empty square, we know for a fact that that is the lowest empty square. So how do we start from the bottom? Like, we could technically go like start from there and then go down by sevens. And then if we don't find anything, we return -1, because there's the possible chance that there is no lowest empty index on the row that you've clicked. I'm missing something here. And this, well, it's greater than 0. Because, yeah, we definitely want to stop iterating once I has decreased to below 0. We're starting at the board length, but we want to start at the column. Is it board length minus column? So column is 0, board length. Nope, that's wrong. Okay, one sec. I'm gonna get a piece of pen and paper because doing all this in my head, it's just not working. Oh, isn't this just equal to whatever board length is minus 1 times the column? So hear me out here. We want to get the total number of rows. The rows is 7. The rows is definitely 7. And we want to get the last row, which is the 7th row, so 6 actually, plus the column. So this will give us the last row column for every single column, starting at the 6th row, because 6 is this. Oh, isn't it 6 times 7? 5. Calculator. Oh boy. 5 times 6 is 30. No, it should be starting at 36. 6 times 6. The 6th column. The 6th row, sorry. I think this should work, but here we go. Lowest row. So starting from the lowest row index, we're going to be decreasing I until it gets to 0 plus column. Now, we definitely want to test this because I'm not confident. Like, I can just feel the lack of confidence in this function. So here we're going to make the move, and then in the make move function, we're going to call board column. Let's confirm that I actually wrote that correctly before moving on. Oops. So it ran all of them. And the lowest column The row index should be 0, not 1. So it's also off by 1. But it shouldn't be running all of them either. And here, we need to write a condition, and that is like if board at I is equal to player dot none, then we return I. So we actually want to return the index once it's found. But also we're off by 1. And I think that's because this needs to be 35. It's not exactly 36. Refresh. Nothing's happening because I removed the console log. Of course. Let's console log the result of this function here. So one thing I find that's useful is because I know I'm not confident with this function, I'm not willing to move on any further in the code base because then debugging this will be really hard. 35, 36, 37, 38, 39, 40, 41. Cool. So this looks like it's finding the lowest row, and then I do have faith that it's going to find the next lowest row for each column as we click on it as the pieces move in. But that's something we'll definitely make a mental note to test later. So const index. So we find the lowest index, and now to make that move, we just have to say we want to set the state to a new board, and the board will equal to the board, a copy of the board, and we need to update the value. Can you copy and update a value in one line? I don't think so. New board or copy board. Nice. So let's say we copy over the board because we want it to be immutable. Let's call it a new board. And then new board at index should equal to player. And now, of course, we get into the situation where we're not currently tracking who's going. And we're going to have to do that. And so suppose here we were tracking player turn in the state. Whoever just went should be the one to reassign it to that value. However, player turn is undefined. So we'll define it in just a minute. But this should successfully, supposing player turn exists, update the board at that index with that player's value. So let's say we're tracking player turn as, we'll initialize it as player.1, and we need to add it to the state as a player type. And every time you make a move, not only do we update the board, but we also want to toggle the player turn. Let's make that a functional thing here, because I want to make it part of the same set state, because set states can execute like in a different order. So I just want to do it right away here. But the act of toggling a player should still be standalone. So const toggle player turn will be a function that takes a player of type player, and it'll return whose player turn it should be. So if player is equal to player.1, then we should return player.2, else return player.1. Pretty easy toggle player function, but now we can use it anywhere to toggle the player value. Player turn. Cool. So this will now update the board with the new board and the player's turn, whose it is. So now we will successfully be assigning player 1 and player 2 to each of the different board cells. Let's confirm this theory that, it actually does that. We, of course, won't get anything from this unless we actually console log, maybe in the render function, this dot board dot there. So we actually need to be able to see what the board looks like on each click. So notice I'm clicking on a bunch of squares, filling them all up, and it looks like we are able to fill up most of the grid with moves. Let's actually color coordinate them now so we actually see it on the UI. Because there's no real point in debugging this the way it is. It'll be much easier to just look at the UI and have the UI do the bulk of the work. So really, it's when we're rendering cell, we already know the player who owns the cell. So what if we just did data dash player? I want to make it a. So notice if I just type in player here, and I wanted to read in which player this is on the CSS side, player is a number. So writing CSS for a number is definitely ugly. So I don't really want to do that. So instead, I want to get a stringified version of the player. So suppose we had a function called pretty player, or like get pretty player. And we pass in player. And this is going to return a pretty version of what this player ID represents. And let's make this again just a pure function up here. It's a function that takes a player of type player, and it's not going to do anything fancy really. If player is equal to, it's pretty much just a switch. Return no player. Let's say we were doing camel case. So the benefit of like doing this approach is now in the future, anywhere where we use the stringified version of the player, we just have to refactor the get pretty player. And so now the code for the actual CSS is less coupled with the implementation on the JavaScript side of, where are we? The actual player enumerable object. So this is a very effective kind of middleman approach to making data more sanitary. Board.cell at data-player should equal to player 1. I think that's how you do it. Let's say player 1 is yellow. Okay, it's working. Cool. No, 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 no. Whew. Sweet. So, then if we just do player 2, we make it red. Let's get Slack out of the way so I don't click it again. Cool. So we are successfully, now we've got 2 players. It doesn't matter where you click, the pieces all go to the bottom. And we have 2 players. I want to make the colors a little prettier, so pardon me, I'm going to take 2 seconds to give these also, whoops, a little gradient, because gradients go a long way into making something look like reasonable. I don't know how to describe it, but I like it. So I just set the gradients to the same color, and then I actually tweak them in the UI inspector. So now if we grab this, grab the first yellow, make it lighter, grab the second yellow, make it a tiny bit darker, boom. Now we have a pretty yellow. And then let's do the same thing with the red. All we do is grab the first color. That did nothing. Try again. Grab the first color. That did nothing. What? It's not updating. I'm going to refresh. Something weird is happening. Ooh. Why does it have a border? Uh-oh. I'll fix that in a minute. Why is it off to the side? That bothers me. Anyhow, now we have a pretty red. Let's debug this whole border situation. What's going on? I think the width of the parent, because we added padding to it, may not have border box applied to it. Like that's a stretch. Box sizing, border box. I mean, it did fix the original issue. However, now the padding, we need to add the padding. The width is 800 plus 16, so 16. Was it seriously the gradients that did this? Because if it was the gradients that did this, I will gladly undo the gradients and just move on with my life. Is it because I'm zoomed out? Oh, okay. Yep. Gradients are back. Oops. And so the reason that these white arrows are appearing is we did the math correctly. However, I'm recalled zoomed out of my screen. So if you actually zoom in, they're perfect. It's only when you zoom out at a certain point that all those white lines start appearing. Just ignore it for now. It is kind of annoying, but oh well. So we do have the core concept of the game done though, essentially. Like people are making moves. The only thing we have left now is to recognize when a player has won. And then we're done Connect 4. So let's go ahead and do that. Let's remove this console log. And notice like yeah, so far we've had to do very little as far as like writing functions. The functions have all been very short and sweet, which is awesome. So UI is done, the game constants are done, make move is done, check game state. And we've done this. So, finally, check game state. I'll make it a pure function because it can just determine what to do based off of the board that's being given. So, get game state is a function of the board. And it's going to have to do a couple of things here. Check wins horizontally, check wins vertically, check wins diagonally. Now this is a problem I did think about earlier, and I found that there's a clever way of kind of simplifying this thing, in that every time you need to get a slice of 4 squares essentially and figure out if those 4 squares match the player, and then that's the winner. So really, fundamentally, the check winning slice, or is winning slice. The variable naming here kind of implies it's a boolean, so check slice, check slice is winning slice. I don't know what to call this, but you get the idea. Check winning slice and you're going to get a mini board, which is going to be a list of players, potentially. And first, it's going to check if any of the things on the mini board, if there's even a single square that is equal to player.none. That means in that slice, there's at least one square that no player has gone on, in which case, return false. Cool. Player.null. If the cell is equal to player.none, return null, because we know it definitely can't be a winning square. Otherwise, if all the squares are occupied inside the mini board, then we know for a fact that they exist. And now we can actually just do a brute force check of if mini board hits 0, mini board at 1, should equal to mini board at 2. Fun stuff, I know. Return mini board at 1. So it's going to return either false if no one's won, or the player ID of the player if all 4 of the mini board sequence are the same player, because that means that player has definitely won. And otherwise, return false. Oh gosh, there's an ad playing in the background. Stop. Thank you. So we can now use the check is winning slice here to get slices of the board state and see if they win. The horizontal ones are the easiest by far, for sure, because like the slices are very easy to cut because our board state actually is sequenced in terms of rows. So let's say the index is 0, while the index is less than 42. Technically, we could do board.length. What we want to do is we want to create a board slice. So let's say it is board at dot slice starting at I and going to I plus 4. And then if winning result, check if it's a winning slice, the board slice. And if winning result does not equal to false, then return winning result. So we know that for a fact, if this is returning something other than false, then it's returning the winning player. Again, the naming could be better, but I can't think of anything better right now. So we don't actually need to go through the entire board. We only need to go through the first like 3 indices of each row. So we want to actually be going over rows and columns. So here, instead of this being the index, let's rename it to be rows by columns. So this is row, and then for let column equal to 0, column is less than 7. We do some stuff. Move all this code inside the nested for loop. So the row, there are 6 rows. And there are 7 columns. However, we don't have to go through all the columns, sorry. In reality, because we're going up until, so this is just wrong, first of all, this should be, I'm using some poor naming here, sorry. So we have a list that's like 0, 1, 2, 3, 4, 5, 6. These are the indices. And because of the way the slice works, we're just going to slice these numbers. So once the column reaches the 4th column, We no longer need to iterate over the rest because there are no more sequences of 4 that can happen horizontally. So here, only while it's less than or equal to 4, we iterate over the C's, and we do want to go over every single R column. So the index that we're actually going for is the row times 7 plus the column number. And here it's index all the way to index plus 4. And this should give us horizontal wins. And we should be able to test this immediately, I think. So this is going to return winning result. Where do we want to check the game state? Probably after the make move, right? So after someone makes a move, we want to immediately check the game state. And we even have a new board to check the game state on. So const game state. Suppose we actually evaluate the game state here. We pass in the new board. And we also log the game state. Let's see what we get. Our goal is that we're going to get a winning player, 1 or 2, once we have 4 in a row. Game state 1. And then if, let's say, we make the red player win, wait, we can't do diagonal. What am I doing? Can I even, can I make red win horizontally? Red goes here, yellow goes here. Okay, anyways, I think it works. That was embarrassing. Okay, so the horizontal win seems to be working. Cool. And now we do vertical. Let's leave the comment there because it's relevant. So vertical slices are a little different, but we're still going to have to iterate over some combination of rows and columns. So let's just copy paste the core structure, and like ultimately we will get a board slice we're going to call winning result, and we still return the winning result if there is a winning result immediately. However, previously we short-circuited like the columns at 4 for horizontal wins. Now we want to short-circuit the rows for row wins. And so similarly, if there are 6 rows, let's see, I think that means 0, 1, 2, 3, 4, 5, 6, 5. So we want to iterate up until 2, so the row can equal to 2. And then once we get the slices of row plus 1, row plus 2, row plus 3, row plus 4, that will cover all the rows up until 6. And the columns, on the other hand, can go through all of 7. So now the board slice is going to be different. It's actually a list of board at index. Yeah, is that it? Just board at index? Board at index plus 7 for the fact that it's 1 row down. Board at index plus 7 times 2, 2 columns down, times 3 for 3 columns down. So if index reaches 2, then this is 3, 4, 5. So row will successfully go over the 5 vertical win checks. It feels like it works, but I'm kind of not that confident for some reason. Again, checking each individual thing. Someone was supposed to win. No one won. So something's not happening here. What's wrong with my board slice? Board at index. Index is row times 7 plus C. Let's console log the values for R and C. I'm not really sure what could be going wrong here. 0, 1, 2, 0 through 6 for the columns. 0, 1, 2, 3, 4, 5, 6. The columns are correct. And then for the rows, we have 0, 1, 2, plus 1, 2, 3. That should cover all of those. So is my slicing correct? Oh, shit. Why does my core index have a plus C? That's the column. Why does it have a 7? No, that makes sense. What are my slices actually? Okay, so if my slices are being generated incorrectly, let's see what they are. Because there should be a definitive point where when I have 4 in a row, I should be able to see a slice with 4 of the exact same value. There. So there we go. We have a slice with 4 numbers that are the exact same. We literally know that we've created the slice correctly. So that means that check winning slice. Are you broken? Returns 0 to 1, 1 to 2, 2 to 3. If they're all the same, return the value. Check winning slice. I wonder if it has to do with the false check. Is it the Boolean then? Winning result does not equal to false. Can we just throw a debugger right here? Cool. Debugging. Where's my console drawer? Thank you. So winning result, we have a winning player. And we're going to return 1. That looks correct. Are we no longer console logging the result? No, we're not. So wait. What? We're just not console logging the result? Are you serious? Why is this gone? Oops. Alright. Winner. Okay, great. So it actually continues to work. It's just I messed up somehow. Maybe I erased the console log without noticing. So we are now correctly reading vertical slices of the game state. Finally, we need to check diagonals. And of course, if there's no winner on any of these combinations at the very end, we want to check if the board has at least one square where the cell is equal to player.none. If it has at least one more playable square and no winner has been found yet, we're going to return what is the game state that ongoing? Oh, we don't have that. We want to return something that represents the fact that the game is not yet done. So I am going to call that game state. And it's going to have an ongoing variable, which will be -1. And it'll have a draw, which will be 0. And then a player 1 win, which will be equal to player.1. Is this allowed? And a player to win, which will equal to player.2. Great. So this will then return ongoing. Else, if it has none of those above, it will return game.draw. We're almost there. But diagonals. Diagonals are actually a tricky problem. So it'll be easier if we could draw it out. But with diagonals, the way we're ultimately going to approach it is we're going to scan down the array and we're going to check diagonals every time it's possible. And by going in a linear fashion, we're not going to repeat. Because if we did diagonals, let's say, we could do diagonals to the top left and the top right while going down, as well as the bottom directions. But then as a result, we would be checking the same things twice, which we just don't want to do. So instead, we're just going to be pointing down. And we also want to avoid checking diagonals that don't even have the minimum 4 pieces in them. So that means we're going to have to continue trimming down these R and C values depending on where we are. And ultimately checking the winning result. Oops. And we can remove the debugger. Whoop. Right. So first, we're moving from the top left over. We can already check the right diagonal, but we should be ignoring the left diagonal. We're ignoring the left diagonal on the condition that the row value, so if the row value is less than, let's see, the low row value is 0, 1, 2, 3. So long as the row value is less than 3, we cannot actually go to the left diagonal down and get enough pieces. So we just don't do anything. So actually, we're going to write this as greater than or equal to 3 because only when it's greater than or equal to 3 are we actually going to do stuff. Oops. And as far as the other condition is concerned, which is, oh shit, I meant column. I was saying row for the last little bit. I definitely meant column. As you move across the column, you want to be at least in the third column to consider the left diagonal. But also, you want to be at most, let's see, 0, 1, 2, 3, 4, 5, 6. At most, the third column to check the right diagonal, because once you go past the third column, you will again not be able to get enough pieces. So if C is greater than 3, cool. So this is checks diagonal. If it's greater than or equal to 3, down, left is the direction, like down to the left. And here, this will check the diagonal down, right. So, down to the left. Grab all this stuff, throw it in here. The starting index is the same no matter what. It's going to be shared by both ifs, so I'm going to prop it back up outside of the if. But the board slice is going to be different, so I'm going to throw that in here. So the board slice takes the index, and then it's going to take the index and we're moving down, so we add 7. But we're also moving down a column. -1? -1? Oh, -2. -3. So we're incrementing the number of rows, and for each row we go down, we're moving one column to the left. That seems logical. And then we do the win check. So here we are moving 1 down, and we're increasing the column by 1. And that should work. You never know. So we want to see diagonal wins. Moment of truth. Yay, red won. And then we want to check if yellow can win. Red, yellow, red, yellow, red. Let's try that again. And then it should say player 1. The game is ongoing. So we made a mistake here somewhere. I made a mistake here somewhere. Probably an off by 1 error on these diagonal checks. So here, this condition is where the column is equal to 0 and it needs to go down right. So let's see. Shouldn't the condition be less than 3? Only if we're less than 3 or equal to 3 do we do the down right. Yeah, so my condition was wrong. Alright, let's do it again. I think we're almost done. And cool. So now the game continues. We can do a few like little things to make sure that the game actually ends. But essentially we're done. So public render game status. So let's actually say who's playing. Return div const game state. The game state, I want it to be stored in the component state. Here, after every single move. And in order for that to happen, we need to actually add it to the component itself. Cool. So now when we're rendering it, this could also be a switch, but let text. If game state should equal to game state dot ongoing, text should equal to game is ongoing. Else if game state should equal to game state dot draw. Player 1 1. If statements are the funnest part of programming. Right. So this is just kind of cleanup stuff though. Like we are essentially done. But these are nice to haves. So we do this and then we spit out the text here and then suppose we did cool. Property game state. Oh, I probably didn't initialize it. And the initial, yep, game state. Let's initialize it to be game state dot ongoing. Why is this a problem? Game state is either a player or a game state. Screw it. I don't want to deal with this right now. So instead of predefining it as a player, I'm just going to put in 2 here. So game state is only game state. I think it's complaining because I nested the definitions. Maybe not. Maybe it's not. So where do I... What? Oh, this can return a player. So get game state. That's fine. Actually, never mind. Get game state can return a player or a game state object, and so it's complaining that I, in my interface, only call it a game state. But I can totally play a player too, because here, based on my earlier definition, we did player.1 and player.2. So those are valid states of the game state player thing. A game is ongoing. Beautiful tiny text up there. Player 1 wins. Player 2 won. Oh, we can't go in the last square. On the very first square. That's interesting. That is interesting. That is part of the make move. Find lowest index. So is this off by something? 35. Greater than or equal to 0. Yep. We are ignoring the 0th element. And that should cover the first cell. Nice. Feels good. So now we want to be able to stop making moves once the board has been won by a player. So wherever we have make move, I'm also going to quickly check game state. And if game state does not equal to game state.ongoing, then just return. Don't allow anyone to do anything if the game has been won. So the moment the game is won, the game is over. Rather, you can't make additional moves. Done. Yellow has won, and the moment that happened, the game is over. Boom. Yellow wins. I think we're done. I think this is, so let's see, it's about 200 lines of code and a tiny bit of CSS. And we can get Connect 4 working. Just like that. Go us. Biggest takeaways here, I guess, is like, whoops, don't want to move that. Like a lot of the code was really just the check win function. Everything else is pretty straightforward, so long as they're divvied up into small blocks. Yeah. Anyhow, this was fun. I hope you guys liked it. If you want more content like this, subscribe, and please, again, do leave comments about questions or suggestions with how to do this better next time. Until next time, ciao.